Welcome to Scientists Unedited. I'm your host Eirini, and with this podcast, I aim to bring you the stories behind the individuals. We will be focusing on the lives of the scientists of cell and gene therapy alongside their discoveries. In this episode, we will hear the story of Anna Maurer, who changed her life's trajectory by joining community college in the age of 24 while having to take care of her terminally ill mother, the inspiration she drew from this experience, and how she navigated the cultural shock of Harvard to eventually find her scientific love, the AAV particle.
But first, join ASGCT and the Clinical In Vivo Gene Therapy Group at the Children's Hospital of Philadelphia on Friday, November 20th, for a one-day program. Leaders in the field will cover the full spectrum of AAV and LNP gene therapies in a single day. Registration is now open, and you can learn more at asgct.org.
Hi, Anna. We're here in Boston. We're at the annual meeting at ASGCT, and I know Boston is a special place for you since you did your PhD here.
Certainly is.
I actually first met you here at ASGCT, but in 2022, and we started collaborating, but we actually just ended up mainly becoming friends. I know that you have an amazing story, and I can't wait for you to share it with everyone. But like I said, let's start from the beginning of it all, because I know what adult Anna, who loves AAV, is like, but what was little Anna like?
So I grew up in a suburb of Detroit, and I'm first generation college, so my parents did not go to college, and I didn't really I wouldn't say that they didn't instill education as a value in me. They did stress doing well in school, but I never really imagined myself as a scientist or any kind of higher education path. So as a kid, growing up was a little bit hard because of my mom struggled with a lot of health issues. She had some immune disorders. She had a splenectomy, actually, and she had several blood transfusions. And she had stillborn twins. So the twins died from cytomegalovirus, which is a very interesting and ironic fact because today I'm using a CMV promoter in all kinds of research, and most gene therapy vectors have some derivative of a CMV promoter. So part of my motivation being from a tool that we now use every day, I just find that ironic. So this really affected the family dynamic. What happens when you lose two babies? You go into a deep depression. And I think that this is what drove her into alcoholism over a long path. And one of those blood transfusions, she contracted hepatitis C because this was in the 80s before they checked for these things. So we didn't know that she had the hepatitis C until she was incredibly sick. I'll get to that later. So fast forward, I was a very rebellious teenager. Growing up was pretty hard. And I had my first job at the age of 15. It was not in science.
Yeah, okay.
I worked at Boston Chicken back when it was Boston Chicken before it was Boston Market.
And you decided to get a job, and what was the situation at school?
I got a job because we didn't, unlike some of my friends, so it was a single income household. My mom, she went through bouts of good health as well, and she would work at the school helping teach art and computer classes, but it was mainly a one-income household. Of my dad installed draperies and blinds. And there wasn't pocket money for me. I could work for an allowance, which was great because it taught me the value of doing work. Since I was 8 years old, I was cleaning the bathrooms That was like $2. You would get $2. This is the 80s, early 90s. So I learned, if you work, you can get money, and then that's your money. I can do whatever I want with it. So I got a job as soon as I was legally able to pay for the things that I wanted to do that my parents couldn't necessarily afford. And fast forward to being a very rebellious teenager, and I didn't exactly graduate high school with my class. Let's say I went to night school afterwards to complete that. And I had I really had no aspirations of college, and because at that point I was waiting tables and I was making enough money to support myself. So I moved out very young.
Did you drop out of high school?
I didn't drop out. I technically failed. I skipped so much class that I just didn't have the credits to graduate. And so, I just stopped going my last year.
Okay.
Anyway, waited tables. I was living with a friend. It's super fun. You're 18 years old, 19 years old, out on your own, and I liked to party, and I was making plenty of money waiting tables, and that was great. But that's only great for a while.
Okay.
And it's a stressful job. The service industry is stressful. You're taking care of people and relying for their tips, like their generosity for you to make a living. And it's like a physically demanding job. You're carrying things. It's hot. There's a lot of stress. There's yelling. You're running around for hours. And this just didn't seem like the way I wanted to contribute to society. Mm-hmm. Although, servers and bartenders, a very special place in the world. It just wasn't what I wanted to do long term. And so I thought, I'll try community college. I didn't need any grades, or you don't even need a high school diploma to go to community college. Everyone's accepted. And so I enrolled in some courses there. And I was always good at math and science and computer programming. Computer programming was the only thing that I ever got A's in, because I didn't have to try. I was just good at it. So I took courses like math. I think I took math, physics, and biology my first year.
Yeah. So let me quickly ask you at this point. At what point did you decide that, I've had enough fun, I've made enough money, but maybe now I want to go down a different direction?
Yeah. I wouldn't say it was enough money, but I was 24 when I first enrolled in community college courses. And I was still working full-time waiting tables. The schedule is very flexible, so I was able to work at night and take courses during the day.
Okay, so at that point you're doing both.
Right. And then that was going well, and I actually enjoyed it because I was finally doing it on my terms, right? I wanted to take these courses, and I did really well, and I enjoyed it. And then Mom took a turn for the worse, and at this point, my parents were divorced, and so I became her primary caretaker for the year preceding her death. She wasn't eligible for a liver transplant because of the bouts with alcoholism, and they basically told her, get your affairs in order. And that's when we learned that she had hepatitis C this whole time. And so at that time, I enjoyed science, and what they tell you when you're growing up, if you like science, you should be a doctor. And I thought that the experiences that we had in the hospitals with my mother were not great. We weren't treated well. Because we were from a lower income household, and hepatitis C is, traditionally associated with needle sharing and diseases, communicable diseases like that. And plus the alcoholism, we were not treated well. And I was motivated to be a doctor so that I could provide judgment-free care someday to someone's mom who deserved it.
So then did you already know when you picked those classes
at community college that you could be going down that direction, or did you feel that your mom's experience informed this better?
Yeah, that's a good question. I do feel that my mom's experience and having to go in the hospitals so much and take physical care of her, I do feel that motivated me to do something in the medical field. But then I knew that the science was the way to get there, right? That the science courses anyway were the way to get there. And then when she was very ill, I actually had to drop my courses that semester because I still had to work full time, to pay the bills. But then she needed full care. So then when she passed away, I was 25, and then I really kicked into gear with the courses, and I discovered that you can transfer to a 4-year college. My credits from community college actually transferred to the University of Michigan. I was super lucky to have a guidance counselor that said you should do this because if you want to be a doctor, you need to go to a 4-year college, not a 2-year. And so I transferred, and that was when the whole world opened up, and especially science. The courses there were next level, but also exciting. And there I learned about research as an avenue to get into medical school, because you need, one hell of a CV to get into medical school. And so I enrolled they have like independent study courses, and I found a lab. We were studying basically stem cell epigenetics.
Okay, so then the journey starts with you wanting, the scientific journey, let's say, starts with you wanting to become a doctor so that you can become a doctor with, let's say, different values, treating people differently due to your own poor experience.
Yes.
But then how was that journey of, I guess, navigating from, the challenges with high school to community college to eventually, as we all know now, you ended up at Harvard doing a PhD.
Right.
So what was that journey like? How did you end up there?
Yes. So finding the research as a segue to medical school opened my eyes it started to help opening my eyes towards research as a career option. And at that time, I was working at the Detroit Golf Club, and a member there that is an OBGYN, she said, when you talk about your research, you really light up. Have you considered a PhD instead of an MD? And then you can do research as your career. You're still helping folks. And I said, oh, yeah, maybe I'll do that. And then I considered it. I talked to some of my professors, and they said, yeah, you should go for it. So the research to get into medical school was what drove me to pursue the PhD eventually. And then deciding to do the PhD, I applied to University of Michigan because Michiganders don't leave. We don't leave. It's very nice there. And I also didn't imagine that I could get into a school like Harvard. And I think I applied kind of as a joke. Legally Blonde and Good Will Hunting and all of these things.
Great inspiration.
Yeah, I'm going to apply. Hey, if Elle Woods can get into Harvard, I can get into Harvard. And I applied. And I also applied to University of Wisconsin-Madison. They had a great stem cell program. Or they still have a great stem cell program. And UCSF. So I was into the stem cells. I wanted to do tissue engineering because I wanted to grow a liver for somebody's mom who was ineligible for a transplant. So it was all very close to home. And so I was pursuing that track, but I really intended to stay at Michigan. But then I got accepted to Harvard, and I couldn't believe it.
I was going to say, could you believe it?
I couldn't believe it. I didn't know at the time that I was good. I had a good GPA because I had worked very hard, and I was a non-traditional student. I never worked on campus. I didn't go out partying all. I partied with my adult friends, but I had a different value for my coursework, and I worked very hard. So when I got the interview, and then I nailed the interview, and I got in, and that opportunity changed everything. So I took it and I went. First time living outside of Michigan, just to drive your stuff across the country in a U-Haul, which was not the last time I would do that. But anyway, I started in 2013 in the Biological and Biomedical Sciences program at the medical school in Harvard, which is an umbrella program. And so I did most of my rotations with stem cell and regenerative biology folks.
But from our conversations, I always remember you mentioning how, I mean, it was a surprise to get into Harvard because still Harvard is Harvard, but because, you know, you didn't know that you were good and you didn't know that your PI felt that you were good. And then later on you found out that he gave you an amazing recommendation. Right. And I guess I think this is an important point about encouraging trainees because science is tough.
Yes.
So yeah.
Yes, I think this is something I want to carry forward in my career, is to make sure that I give positive encouragement to my trainees. If someone's great, tell them they're great. They may need to hear that. And if I had known, I'm very happy the way my path turned out, but, you know, maybe I would have done something different or earlier in my trajectory. Mm-hmm. But it's important to hear that. And, I think confidence is it's the magic sauce. And if you feel like you can do something, you're more likely to do it. Yeah.
Yeah, I do think it's important to take a second here and definitely acknowledge and appreciate that, because again, science is hard and it is important to give the younger trainees this encouragement and support to keep pushing and, you know, surviving at times.
Right. Well, and to be fair, my PI, Tom Kerpela, during my undergrad research, which was like 3 years, he does support me. He just has a different way of doing it, right? He's not going to outright tell you that you're great. And, you know, he's kind of has the old school air of like, he's the older generation. But yeah, he wrote me an amazing letter of recommendation, I found out, and that was what helped. So now moving forward in my career, I'm writing letters of recommendation for students now, and I know how much it can mean. Like, it can change somebody's trajectory. So
it does change people's lives from also personal experience. Yeah. Okay, so you are in Harvard, I guess.
It's crazy.
First comes the shock, then the excitement, then the reality. So how was life at Harvard?
At first, it was very hard. It was a culture shock. Boston is very different than Michigan. Michigan's a little slower pace, and everyone's incredibly friendly. The Midwest niceness, that's a real thing. But if you grow up there, you don't realize that that's a different culture and that people aren't just by default nice to everyone. So it was strange. But then there was I was about 8 or 10 years older than my cohort on average, which was, 65 students, and most of them had only either come straight from undergrad or spent just a year or two doing research, but no one was in their early 30s, right? So, and I got made fun of for my accent, which I don't have an accent. They all had accents.
Well, we all have an accent, so...
Exactly. And, I think it's just mean to make fun of someone for how they talk. Yeah. And I was always a very friendly person and, seemingly popular. So to come to a place and have people just by default not even know me and not be nice, it was just culture shock to me.
Yeah.
But, of course, I did find my tribe. It took a moment, but... I did find my people, and then once there was a few people, and then I started doing I was doing well in the courses. My research went well, and eventually, by merit, I was accepted because
so this is
I
how
belonged.
You found your crowd. Yeah. You belong to academic merit. Okay,
right? And So I hope everyone else learned that some little weirdo may be someone that you really like later. right? And so by our 5th year in the program, my now husband and I were elected to give the opening remarks at retreat, which was like a really big deal. The BBS retreat was a big deal. So I slowly was accepted by everyone. But yeah, the culture shock was interesting, but it was great for me because, like, I think, and here's another thing that I hope people can take away is like getting out of your comfort zone and going and putting yourself somewhere totally different. This is how you grow. You learn when you're surrounded by different ways of thinking and living and doing things. You can see those things that you like, and you can take and adopt those. You leave the things you don't like, but you take what works for you. Society is a bunch of learning and communicating with each other.
I mean, I'm glad that you also gave it a chance, because I guess that's an important point to make when you come from a different cultural, socioeconomic background. Obviously, the first barrier is that the access to academic opportunity.
Yeah.
But then once you join, also you will find a new world there, like to your point, and at times probably difficult to find a sense of belonging. But eventually you found your crowd, and you had a great time, as I know now. Like you talk about these years fondly. So I'm glad, you also gave it a chance, and they also gave you a chance. So.
Yeah, thankfully. But yes, it's both sides. We both gave each other chances. So, yeah, the comfort zone, I was still doing research, and science is very much a comfort zone for me because I love it and I feel like I'm pretty good at it. So I made it with all the other things eventually. We meshed.
Okay, at this point we have established that you love research and that you're actually really good at it. But the beginning of your research journey, it started because you wanted to make liver transplants. But eventually your career ended up being in AAV biology. So how did this happen?
As I mentioned, I was really fascinated by the promise of tissue engineering and stem cells. In these umbrella programs, these umbrella PhD programs, in any PhD program, really, when you enter the program, they have orientation events where there's poster sessions and there's, labs that are recruiting students will have a poster, and you can come and meet the PI or perhaps some postdocs and just discuss the research and see if it's a fit, and you might want to rotate. And so these poster sessions at Harvard were at like all the different campuses. They had one on the main campus of the college, like in the Harvard Square campus. They had one at the medical school. They had one at Charlestown. And so there was research everywhere. And at one of these, there were 2 posters with Nobel laureates, and all of the students were surrounding these people, and true to form, I've always kind of liked to do things differently than everyone. So I said, well, if everyone wants to do that, I'm going to go elsewhere. So I looked for someone that wasn't talking to anyone. And, well, I was kind of lonely at the time myself. So I thought, you know what, I'm going to talk to someone who's not talking to anyone. And I met Luc Vandenberg, who at that moment was not talking to any students. And he told me about gene therapy. I had never heard of AAV, or I had heard of viral vectors, but I had not heard of AAV gene therapy. And he showed me the video of a child that had received a treatment for LCA, and with a video of him navigating this maze. Corey Haas, I believe was his name. This was like in 2009. The treatment was done by the team at CHOP, but this is, fast forward to 2013, and Luke's showing me this video of him not navigating the maze at all, and then totally crushing it several months later after this one and done therapy. And I was very motivated by that. And then he showed me the AAV capsid, and then I was completely captivated because it's beautiful. Its symmetry is beautiful, and
so it was love at first sight.
It kind of was. And, he told me about what they were doing in the lab. At that time, they were just starting the ancestral sequence reconstruction to make these ancestral variants. And I thought that sounded so cool. I said, you know what? Well, one of the advice I received along the way was you should do a rotation in a totally random lab, something that you didn't. I had planned out all of these very specific rotations, and I did have time for a fourth one. And so I said, you know what? I'm going to rotate. And it was a vibe. I knocked out my first AAP and found that in some of the serotypes we were able to produce some titers without AAP. And, when you not just like nailing your rotation project, being a motivator, but like I was fascinated by gene therapy and like the culture and how the promise of cell and gene therapy. My first ASGCT meeting was 2014, and I was still just rotation student at the time. And so coming to this meeting and just being like, oh my gosh, gene therapy was for me. And so I abandoned my long-term goal of like designing livers for transplant, not because I don't believe in that or, still have a lot of hope for that, but I just found my niche in AAV.
And fast forward to today, so now you're an assistant professor of biophysics at the University of Michigan, so you did go back home.
I did. That was kind of always the goal. After I decided a research track, I wanted my own lab, and I did want it to be at the University of Michigan.
And what does your lab there, what do you guys study there?
We are studying how the AAV capsid assembles. A lot of it is through the lens of the host cell. So all the host and viral factors of capsid assembly, which is important for producing gene therapy vectors. And then we're also really interested in how the DNA that those capsids deliver is processed. At the end of the day, that's the stuff of gene therapy. It's that DNA that remains in the cells. And so how do we ensure that those become stable, transcriptionally active pieces of DNA for the lifetime of the patient?
So, on the one hand, you have lentiviral vectors that are derived from HIV, and because it's a deadly pathogen, there's been a lot of research of its biology. So we have a somewhat decent understanding of, how the virus enters the cell and how it replicates, etc., etc. But it's been very difficult to engineer. In my PhD, literally 99.999% of any change I introduce would just break the virus. But then on the other hand, you have AAV, which is a joy to work with as a molecular biologist. The capsid is really flexible to work with, and personally, I inherited this fascinating project where a single point mutation can change the tropism of the AAV capsid I was working with, which was obviously very exciting. But at the same time, we don't quite understand AAV biology, I don't think. It's not as well studied, as it doesn't cause human disease. And recently, AAV had several bumps in the clinic. So what do you think the field, the AAV field, should be working on now?
Yeah, I do think that the lowering doses is at the forefront. We have these outstanding tools. We know they work, but more is not better, right? Like in cases where we're not getting enough expression, increasing doses can't be the answer. So if we can learn how to make that particle function better, we can effectively lower the doses. And there's already a lot of excitement around that in the capsid engineering space, transducing correct target tissues, etc. And so I think if we keep it, just expand that a little more and move things as a whole toward lower doses, I think that's the most pressing issue right now. Yeah.
So as we're reaching the end of this conversation, let's change gears a bit. What I wanted to ask you is, what do you think the general public gets wrong about the life of a scientist? Or, what would you like the world to know about a career in science?
Yeah, what does the general public get wrong? The traditional view of a scientist is this very solitary thing. Somebody alone in a lab tinkering away at stuff and working late into the night. So this is all true. Yes, we work late into the night, but it's not a lonely thing. Science and research, it requires collaboration. It requires a lot of other people. It's not a solitary thing. I think that's a misconception.
On a more personal note, what would you hope that people can take away from your story?
A couple of things. So tell each other we're great, and don't forget that a great scientist can come from anywhere. Someday I aspire to be a great scientist, but I came from random anywhere. And there's a lot of, there was previously a lot of focus around diversity, because people thinking in different ways coming together make magic happen. You'll come together with diverse minds to think in ways that haven't been thought before and come up with new solutions to possibly very old problems, right? So great scientists can come from anywhere. I also think that it's important to take care of your mental health. If you are struggling with anxiety or depression, as my mom did, and she never sought help, it was stigmatized back then. But a lot of scientists struggle with anxiety or depression, or talk to someone, right? Don't take care of yourself. I think self-care is a really important thing, and mental health is a really important part of that.
These are all very hopeful messages. So support each other, tell each other you're great,
and collaborate. Right? Science does not happen alone.
And scientists can come from all.
Right. Let's all work together and let's cure some of these diseases.
Okay. On that very, very hopeful note, I would like to really thank you for sharing with us your story today. And I really hope that I can, serve as hope and inspiration for the younger generation out there that
That's
might
the future.
that might not be coming from a traditional path, to use your story as an inspiration to, enter the world of science or any other world that they might be hoping to enter. And you can be great at what you do, no matter where you come from. And
and the youth are our future. So come to the gene therapy side.
Awesome. Thank you again.
Thank you.